Okay, video 5, the final video associated with assignment 4, research methods. Summing up and applying the information we've learnt in the previous 4 videos for task 5 and 6 of your assignment. All about numbers. So we've now gone through each of these 4 stages of quantitative data analysis, and this assignment is essentially there for you to, this task is there for you to apply what you've learnt to a difference and a correlation test. And most importantly, this is where you'll gain your merit, having to justify your selection for the test that you choose to do. Same scenario, and there's our process. So organise your data, present your data, do some descriptive statistics and do some data analysis and justify why you've done or chosen each element of that process, and that will be merit. So, as I said, task 5 will involve you doing a mini experiment and using the results of a test for difference from the data that you've collected, and task 6 is doing exactly the same process but for a test for correlation. So, in the mini experiment you will have already collected some data sets, and we're very lucky that we can send off that data to the guys at Chichester Uni, and they will put that data into SPSS and kick out some results back to us. And with those results you literally follow the format in the assignment brief, so it's worth just showing you quickly the assignment brief. We've done tasks 1 to 4 previously, and now we're going to go through tasks 5 and 6, which will look a little bit like this. So task 5, you'll be expected to write the hypotheses in this section. This will be your main merit section, so where you justify the process of all the tests that you have chosen to use. This is you presenting your results, so there'll be the descriptive statistics, any graphs, tables, charts that you choose to use, and a very brief conclusion relating your results to the original null hypotheses or alternate hypotheses. So same sort of progress there. Similarly, in fact exactly the same process for correlation. And I just want to take a moment to exaggerate again that if you go through this process and you do it, you'll essentially get a pass. But what's important for merit is that you can explain and justify why you've used the process, why you've used the test, or why you've chosen to use a particular format of graph or chart to present your data, and that will get you the merit level grade. Here's just a very quick reference to the assignment brief and the process of what you've got to write through in that. I've shown you that already though. And then here's a set of data. I'm going to go through an example for a test for difference and then eventually a test for correlation, but you'll use the data that you collect. So we've got here 10 subjects. We've got VO2 max values data for a multi-stage fitness test and a Chester step test. And we're going to use observe this data to start off with and help us determine eventually what statistical test we'll use to test for difference. So what type of data is it is an important question, and I'm hoping that you know that this is continuous data. We can identify that there's less than 30 subjects, and that because the same people did this test and then did this test, it's paired data. So that will help us in a minute determine which actual test to use. Before you do that, you've got to write your hypotheses though, and based on this, the null states that there will be no significant difference between VO2 max values achieved during the multi-stage fitness test and Chester step test. And you know that the alternate hypothesis basically reverses this and states that there will be a significant difference. But you need to be able to write this out in full in relation to the difference test that you're going to do with your data. So, merit. You need to justify what statistical test you are going to use. Why is it appropriate? What level of significance are you going to use? And importantly, why? So merit is very much explaining and justifying. You might remember our decision tree in terms of our process of determining what test to use. Now, 2 sets of or two sets of data, our multi-stage and our Chester step. So we go on this route. It's not nominal, it's continuous data. There are two categories, as we've just said. The same subjects were involved in both categories. We're going to be assuming that the data is normally distributed. Therefore, you'll be doing a paired samples t-test. But your justification will come from explaining why this process is the right process to go through. Why? And I've kind of summarised it there. Because of these things, we'll use a paired t-test. Here's another little visual of the sort of criteria for a parametric paired t-test. So samples are matched, they're paired, it's actually continuous data, we're assuming normality, and there's a sample size less than 30. So, results. You choose how to present your results, and you need to be able to justify your choices. Do not, in the results section, discuss what your results imply, purely present them in this section. You actually sort of get into the meat of discussion in the discussion section. So results is very much just about presenting what you've found. Use tables, graphs in Excel. Present your descriptive and statistical results. So you'll be stating the means and standard deviations. You'll be stating your statistical results that I will show you in just a moment. But remember, you don't go into discussing them. Make statements, don't discuss why. So here are the descriptive statistics for the two sets of data I'm using in my example. And this is a nice way of presenting it in this table. Table 1, so there's my reference. Here's the title of the table, or description of the table. Clearly presented data, very easy to get the important sort of facts from it. You almost want to think of your observer, the person reading your work, as being very lazy, and you need to make it as obvious as possible for them. So this is presentation of results, and the next thing to ask yourself is, well, what can I observe from this descriptive data? Does it tell me anything? So from your third video, task 3, we talked about central tendency and variability. You can clearly see that the Chester step results have a slightly higher mean. However, the standard deviation for the multi-stage fitness test is much higher. It's much smaller for the Chester, which means that these results will be more tightly packed around the mean. These results were more variable, so people will have had quite vastly different results. Remember, I've shown you graphs of a wide, low, or a narrow, steep normal distribution, and that might be indicative from this detail. So significance then, levels of significance, to give our experiments and results some clout. You should know that the standard or the typical value or level of significance is 0.05, and what this means is that 95% of the time, 95 times out of 100, you can trust these results if your p-value fulfills this 0.05. So it's not likely to be luck if you sort of comply with this level of significance. And also know that there is a 0.01 level of significance, and if you comply with that, it shows that your results are highly significant, not just significant. So here's our t-value, the difference test, the paired t-test value. So data was put into SPSS in order to compare the means or the averages of each data set and to see if there was a significant difference. And the t-value is minus 3.23. The p-value from this is 0.002. So we can tell, actually, let's just break it down, because this information is less important to you. Nowadays, you don't need to be able to translate this particularly, and we certainly don't. So 17 refers to what we call the degrees of freedom, which is the total number of subjects minus 1. So we had 18 minus 1 is 17. And previously, you'd have to look these results up in critical value tables, a bit more complicated. Nowadays we just use software, chuck in the information and it gives us an answer. So this t-value is what you'd have got from critical value tables. So most importantly, we've recognised that this is our p-value, the 0.05 significance level, and we have to compare these two results. So the calculated p-value from our test comes out as 0.002, and because it is less than 0.05, we know that there is a significant difference between the two sets of VO2 max data. So because this calculated value is less than our level of significance, we can see that there is a significant difference. And you'll present those results in the results section, and in the last little bit you need to write a very brief conclusion and discussion. Why do you think that might be? You always start by because we have that result showing there is a significant difference, you will reject the null and accept the alternate hypothesis. Revisit the results briefly. Give a short discussion on your reasoning. I don't need to go into loads of detail in this particular thing, just a little bit of thought as to why that might be. So task 6 goes on to a correlation test, and again I've gone through an example for you. So remember our decision tree, we go through the processes. It's very likely you'll have continuous data, and therefore we'll use Pearson's product moment correlation test. So that's the process, and again remember this is what you need to be able to explain and justify in terms of your results. So collect the data, we've got data, send it off to Chichester, and then follow the format in the assignment brief as you know from the previous task. Here it is, just to show you, and remember that we can use scatter graphs, or this sort of format of graph, to get a visual sense of if there is a correlation or not, and that's a nice thing to include. Again, there's just a reminder of what the graphs mean, or what the -1 or +1 values mean. So here's my example. Height and mass values were taken in centimetres and kilograms. This is the line of identity, and you can see, well, this is your observation here in terms of if there is or not a correlation. There's probably a little bit of a correlation, a sort of a loose correlation there, I'd say. Results show, so this is a bit of a different format, a little bit more confusing, but we'll pick out the important bits. Pearson's correlation, so the R value is 0.758. Now, that was the equivalent of our t value before, so we know that nearer 1 shows quite a strong correlation. 0 is none, and minus numbers towards negative correlation. Now, this R value equates to a calculated p-value of 0.001. And again, we know that because this value is lower than 0.05, we can see that there is a significant correlation. So there's a statistically significant relationship between height and mass. So this is a very strong correlation. So lastly, another example to quickly check out, standing vertical jump and acceleration over 10 meters. And actually in observation there we see a very different pattern, or little pattern at all. Again, that's quite indicative of results, worth having a look at. Our R value comes out, our correlation coefficient comes out at -0.170, and our calculated p-value at 0.5. Now, 0.5 is clearly higher than or larger than 0.05, and this suggests that there is no correlation between standing vertical jump height and 10-meter sprint speed. Now, you might think, well, actually it's all power, jumping and sprinting. However, in discussion it would be worth mentioning that perhaps the muscles that you use for one are different from the muscles that you use for the other, and that might account for this variation or this lack of relationship. Okay, so you need to be able to describe the process of the difference and the correlation test, and justify your choices of presentation, of organisation, and of statistical analysis in order to get merit.